Alright, this is our last video for multi-digit whole number operations. We're kind of going to take everything that we learned and talked about and have done and kind of build on that for our last step in dividing. We're going to estimate quotients, we're going to reason about where we should put our decimal, and we're going to divide our dividends by two-digit divisors. So let's do that today and see where we go. So first I got two problems for you. 904 divided by 32 and 456 divided by 16. Go ahead and pause the video. I want you to try these. Remember to estimate, solve, then check your answer, see if everything works out. And I'm going to throw those algorithms up on the screen. So the first one, 904 divided by 32, you should have gotten 28 remainder 8. And 456 divided by 16, you should have gotten, whoops, you should have gotten 28 remainder 8. So I ask you this question, and I want you to think about this, and we'll talk about this as well. Are they the same? While they're the same answers, 28 remainder 8 and 28 remainder 8, it would be similar to 4 plus 4 and 6 plus 2. Both of those answers are 8, but are they the same? Right? Are these equivalent equations? And because we have different numbers, it's likely that they may not be, but let's find out for sure, and that's where this idea is going to take us. So first off, let's get rid of this first problem, and let's talk about how we figured this out. So when we figured this out, we estimated the 904 divided by 32, and we estimated it to be 90 tenths. We renamed 904 to 900, which is the same as 90 tens, and we rounded 32. We should have done that first because it's our divisor, but we rounded 32 to 30, and we got 3 tens. Now, in the process of doing this, I realized, and maybe you realized this too, that 3 was way too big, so we dropped it down 1, and we had 2. 2 times 32 is 64, and 90 take away 64 is 26. We brought down the 4 and renamed that to 264 ones. I rounded that to 240 ones, divided that by 30 again, because we don't want to change our rounding of our original divisor, and got 8 ones, which is what I have left over, so I have 28 remainder 8. Now I ask you the question, is 8 ones equal to 80 tenths? Yes, it is. But is there a digit in the tens place? Is there a digit in the tens place of 904? I'm sorry, in the tenths place. In the tenths place. There is not, right? But couldn't we rename 904 to 904 tenths? I'm sorry, 9,040 tenths? We could. By simply adding a 0, we do not change the number, but we can continue our problem, and that's what we're doing. So when we rename our problem, here we go right here, we can rename it to 80 tenths, and it's just so nice this time that we don't have to estimate it, but we do have to estimate our divisor still. So in doing so, it's 80 tenths, and what I'm going to round 80 to is I'm going to change the 80 to 60, 60 tenths, and so I rounded 80 to 60, and that would be 60 tenths divided by 30, which is estimated to be about 2, and that is tenths. Where does that tell us to put it? It tells us to put our tenths in the tenths place. And so we do that. 32 times 2 again is 64. Okay, since we did that in the beginning, and we get a remainder of 16. Now we can continue this. Since we renamed it once, we could rename it again and turn that into hundreds. 160 hundredths. And what's nice about 160 is we could round that to about 150 hundredths, right? Because we're doing our estimating, and divide that by 30, And the reason I rounded to 150 because 15 is a multiple of 30. Or, I'm sorry, 15 is a multiple of 3, and 150 is a multiple of 30, so we know this as 5 hundredths. How do we write 5 hundredths? 0.05, right? 0.05, and so that's going to go in the hundredths place. So that's kind of what we're doing, right? And 32 times 5 is exactly 160. And now we don't have a remainder. And how do we check our answer? 28.25 times 32, same way we checked it before. So that's how we would do that, and that's what we're doing with these problems. Let's try it with the other one. So we had our other problem, 456 divided by 16. And what did our estimation look like? But this, so we estimated 456 to be about 400, which is 40 tens, and I estimated 16 to be about 20, so it's 40 tens divided by 20 and 2 tens. Worked out perfect, and I had 13 left over and brought down my 6 for 136 ones. I rounded that to 140 ones divided by 20, got 7 ones, realized it was too small, and went up to 8. 8 times 16 is 128, and we have a remainder of 8. Again, we can take that same idea that we had previously and say, all right, well, it's 8. Couldn't 8 be 80 tenths, right? And it could. By just adding a decimal, we can turn it to tenths, and we can continue with our estimating. So if we have 80 tenths, we don't have to change this one at all because we have 80 tenths. Divided by 20, and we get 4 tenths. And so we can write 4 tenths up here. So it's about 4. 16 times 4 is 64. And we have 16 left over. Wait a second, we have 16 left over. It's exactly what we have, so we can fit another group of 16, and so instead of this, 16 times 5 is actually 80. It would have gone in nicely, so we're going to change that to 5, and that would give us, that would take away that other group of 16, so we don't have a remainder. So now our answer becomes 28.5. Our answer is 28.5. How do we check it? 16 times 28.5. So that is how we would do that. We can extend the problems by simply adding zeros to the end of our decimal and getting exact answers. It's going to be more accurate. So then when I ask you, if we go back to what we had originally, are these the same? Are they the same quotients? They actually aren't, because one is 28.25 and one is 28.5. So that's how we would do this, and hopefully that kind of gives you a better understanding. We're going to work on those in class. Check it out, do a couple problems, see what you come up with. Good luck.